You'll see all kinds of names. You got the T, the wall, the Gaussian, the chi-square. This one we just talked about in 244 today. The normal, we'll talk about that today. The beta Pascal, the geometric, I mentioned that one to you guys a little bit earlier. Geometric, the one you used it for was when you were analyzing the Gambler's Ruin. The geometric is also often used with robot arms putting parts on cars. So one of the big discussions about mass-producing automobiles is they have robots replacing humans in a lot of places. And there's a problem with that, right? What's the problem with a robot replacing a human? Besides the ethical ones and the financial ones.
They can't tell if they're doing something.
The problem is, if the car comes in and it's not exactly where it should be, the robot arm might try to put the door as to where the car should be, and therefore miss and repeatedly miss. So the geometric is used to say, okay, if the robot gets it correct, if it clicks or the part goes in within the first 3 trials, then all is well. If not, stop the belt, send a human out to fix the problem. That's not binomial. It's kind of binomial in that it either gets it right or it doesn't get it right. But it gives it 3 tries. It might get it on the first one, it might get it on the second one, it might get it on the third, or it might not get it by the third. That's not a fixed number of trials. That's what shifts it over to geometric. It's a fun distribution. I don't make you guys learn it because it's not that well used in your fields, most likely. Here's some other ones that are super fun. This one right here, the Benford. One of my faves. It's a neat way of checking whether or not counterfeiting has happened. This guy Benford, the statistician Benford, I forget what era he was from. He had what's called Benford's Law. And we'll study this in 244 if you go on that journey with us. Digits in currency and voting registration and all kinds of other applications aren't uniformly distributed. There are 10 digits, 0 through 9. There are not, if you look at like check numbers or the amounts checks are written for, the number 8 doesn't show up as much as, say, the number 9, as much as the number 10, as much as the number 2. There's a distribution that Benford proposed when he looked at lots and lots of data, and he has what's called Benford's Law, which gives the percentages these numbers should occur. And if too much deviation occurs from that distribution, it's a good indicator that maybe some counterfeiting is happening. They used it in the Iraq election back in 2010, I want to say, to show, or at least to imply, that some of the ballot boxes had been stuffed. Because the numbers that were coming in weren't matching what they should have matched. That's fun. Totally interesting. Also extraordinarily specific. So that's one right there. The exponential is tied to server capacity. The Poisson, one of my favorite, it's how they keep track of lighting. You ever sit at a light? My favorite right now is Newport and Wall Street, going eastbound on Wall Street. Now, as a bike commuter, it's slightly uphill because I can hold a track stand all day long. But that freaking light stays red. Far too long for traffic. Wall Street turns green, traffic clears out, stays green. Traffic is cleared out, it stays green. And I hit it multiple times during the day, afternoons, early mornings, late afternoons, early afternoons, and it's always mistimed in my opinion. So the Poisson distribution they're using isn't the right one. It's not the right one. In my opinion. Hypergeometric, it's what governs Powerball, probabilities in Powerball. Also governs probabilities in that little game you guys analyzed last week with the pick 4 from New York State. So all of these guys have applications. It's just that some of them are so specific they're not worth spending a lot of time on. At least more than the 5 minutes I just introduced them. So what I want to focus on are just 2. We've already talked about one. I want to show you one that it's connected to. Recognize that guy up there? Binomial, red circle, first top red circle, binomial. Notice what he's linked to. He's linked to something called the normal. Now you guys don't call it normal, you call it something else. You call it a name based on its shape. And you've been talking about it for 8 weeks now. Maybe even more than that. Probably even more than 8 weeks. But I want to focus just on those 2 and not on the rest. And you know what? Let's break now. I got to get a YouTube video up, which I'm sure is not linked correctly. I want to make sure the sound works because I want to show you how it all ties together. And again, to answer Sean's question about how do you find all this crap, it just kind of shows up on its own. Okay, take 5, get some air, get some water. We'll come back.